Alright, I want to talk about adding vectors in 2 dimensions in this video. Here we talked about 1 dimension vector addition. That's pretty simple, subtraction and addition. This is going to be just a little bit different, and actually different, but we've already done this, you'll see. We're just putting a little bit different words to it, a little bit different spin on it. We're still going to add vectors tip to tail with 2 dimension, and the resultant vector is still going to have a magnitude and a direction. So that's the same, and in order to do that, I just want to start with this problem and go through the steps of how to do it. I think we've actually already had this problem in a previous discussion with displacement. Let's read it again. A hiker travels 8 miles east and then 2 miles north. How far is he from where he started, and in what direction? Well, you might remember already that we first drew that picture, and we drew it this way. Right? And you might also know that to get the total displacement, which is how far he is from where he started, we ended up doing Pythagorean theorem. But the fun part is that before we communicated directions in terms of north, south, east, west, left, right, etc. Now we're going to use angles. We're going to use geometry. So I'm going to go step by step through this. The first thing I want to do is draw the components, which I have already done. And I want you to notice about the way I drew these. I followed the vector addition rules, which are still in effect. I drew the head of the first vector to the tail of the second vector. In other words, tip to tail. Resist the temptation to draw these vectors like this. That's not correct. That's not tip to tail. That's tail to tail. Besides that, this is not something that a hiker could actually do. I can go 8 miles east and then from there 2 miles north. But I can't start out in one place, split in 2, and go 2 miles north and 8 miles east at the same time, which is what this picture communicates. Also notice that if I were to find the resultant velocity in this direction, not only do I not know what direction this thing is going because there's 2 heads here, it's also in a different direction than what we drew in the first place. 8 and 2, this is our resultant. That's a different direction than what this is. So it must be drawn tail to head like this. I drew the components correctly, and now I'm going to draw the resultant. The resultant, according to our vector addition rules, must be drawn tail of the first to the head of the second. Tail of the first, head of the second. It must go in that direction. It's important that it goes in that direction. Next, we're going to use Pythagorean theorem to calculate the magnitude of the resultant in this case. So this is my resultant. We already know how to do that. So 8 squared equals, or not equals, plus 2 squared equals r squared. So r is going to be the square root of 8 squared plus 2 squared. And if you work that out on your calculator, you'll find that you'll get 8.25 miles for the resultant. This is our magnitude. That's the number. That's the size, the length of that resultant vector. But now we still need to find the direction. Okay? And to find the direction, we're going to use geometry, SOHCAHTOA, to calculate the angle. We're going to use the trig functions. And you might remember SOHCAHTOA, chief SOHCAHTOA, sometimes it's called. The S on the SO stands for sine, C stands for cosine, and T stands for tangent. These are the trig functions, trigonometric functions. Trig, TRI, that TRI prefix stands for 3, as in 3 sides and 3 angles, as in these are the functions we use to analyze triangles. You need to know that what these SOH, CAH, TOA, these letters stand for something. S is sine, and the O and the H in this case is opposite over hypotenuse. And you might say, well, what does that mean? If you can't remember this, here's what I mean. We call these sides 3 different names based on what angle we're dealing with. Opposite, adjacent, and hypotenuse. Those are the 3 names for our sides. In order to figure out what they are, we first need to know where our angle is. And for us in this class, our angle, which I'm going to symbolize as theta, Theta is always at the tail of the resultant. Always. So if we look at our resultant here, that's why it's so important to draw the resultant in the right direction, because now I know that the tail is down here, which means my theta is here. I really only have two angles to choose from because I already know this one. I already know that's my right angle. So I'm going to choose from this one or this one. Since this is the head of the resultant, I want the other one at the tail. That's my theta. So I name my sides in reference to my angle. This 2 over here is opposite my angle, so I call it the opposite side. This 8 is adjacent my angle, so I call it the adjacent side. And you might say, well, wait a second, the R is also adjacent to the angle, and adjacent means next to, if you don't know that. And you're right, R is adjacent to the angle, but we have a special name for this side, and it's called the hypotenuse, and you spell it like this. The hypotenuse. The hypotenuse is the side that is always opposite the right angle. Opposite, adjacent, hypotenuse. Hypotenuse will always be this side, and the opposite and the adjacent side may change based on which angle you're talking about. So let's go back to our trig functions. Cosine of theta now, CAH. The A stands for adjacent, the H stands for hypotenuse. Cosine of theta equals the adjacent side divided by the hypotenuse side. That's what this over means. It means divided by. Tangent theta, TOA. O stands for opposite, A stands for adjacent. Tangent is opposite over adjacent. So I'm going to use these trig functions to find my angle here, because I need to find the angle in order to accurately communicate the direction of this resultant vector. In order to find the angle, I'm going to use the trig function that incorporates the 2 that I know. And I'm going to make believe right now that I don't know R. I'm going to make believe that all I know is this 2 and this 8. 2 is the opposite side, 8 is the adjacent side. So I'm going to use a trig function that incorporates the opposite and adjacent side, and that happens to be tangent. So I simply write down my equation, like the E part of the guess method. Tangent theta is opposite over adjacent. Okay, and now I'm going to substitute numbers in there, the S part, and the opposite side is 2, the adjacent side is 8. 2 things you need to make a note of right here. Number 1 is that your calculator needs to be in degree mode. Needs to be in degree mode. Number 2 is this. If you are looking for an angle, you must use the inverse function. Here's what I mean by inverse function. Look at your calculator if you have one. I hope you do. And if you find sine, cosine, and tangent, those are your trig functions. Look closely. You'll see that above those functions is sine to the -1, cosine to the -1, tangent to the -1. Those are your inverse functions. Those are your inverse functions. To get to those, you have to hit the second key. So literally in my calculator, to get this, I would need to do tangent, the inverse tangent actually, of 2 over 8, which is what I got here. And I don't even have to do this math. I can punch this directly into my calculator. Second tangent, might want to turn the calculator on. Second tangent, 2 over 8. I don't even have to do that math. I can punch it in directly like I see it, hit enter, and we get 14.0. Therefore, my angle is 14 degrees. And I'm almost finished. My final answer would be that my resultant vector is 8.25 miles at 14 degrees north of east. Because this vector right here that we're dealing with is not going straight east. It is elevated at a 14-degree angle north of the easterly direction. And that is your final answer.